Lint passed, the type check was clean, the tests you wrote went green, and the AI looked you in the eye and told you it works. So you shipped it. 2 weeks later, a real person, using it the way real people actually do, hit a behavior nobody ever tested. And it was broken the whole time. Every check you had said yes. The software said no. If that has happened to you even once, you already understand the entire reason this module exists. So let me say the thing this whole module turns on. A screen is not a system. A demo is not an app. Speed is not durability. Those 3 lines name the exact gap most operators fall into right after their first build ships. The gap between all my checks passed and it actually works for the person using it. And that gap is wider than it looks, because the checks you trust most are the ones that quietly can't see it. Here's what I'm going to give you in this module, so you know where we're headed. First, in this lesson, the failure itself, what static success really is, why a clean lint and a passing test and a confident AI can all be true at the same moment the thing is broken, and why that gap gets more dangerous, not less, the bigger your project grows. Then, 4 lessons that close it. A definition of done that travels, not a one-off checklist for one build, but reusable standards per kind of work, so the AI knows what finished means before it writes a line. The hunting discipline, where to actually look for the bug when every obvious check has already passed. Pre-ship checklists that compound, the list that gets 1 line smarter every single time something breaks on you. And the close, where we point at where this scales, the automated, production-grade version, and the honest line about what lives in premium. By the end, your verification stops being a hopeful glance at a green checkmark and starts being a discipline that catches what the green checkmark never could. So start with the trap, because you have to see it clearly before you can climb out of it. Let's be precise about what your checks are actually telling you, because the danger is they all sound like proof, and only one kind of proof is the kind you need. Lint is a style and syntax check. It reads your code without running it and flags the things that are formatted wrong or shaped wrong. Useful. It keeps the code clean. It has no idea whether the code does the right thing. The type check is similar. It confirms the pieces fit together, that you're not handing a word to something that expected a number. Also useful. Also completely blind to whether the result is correct. It compiles just means the code is well formed enough to run. It is the lowest bar there is. None of those 3 ever ran your software the way a user runs it. They checked the code at rest. They never watched it move. Now the tests? Tests are better. A good test actually executes a slice of your software and checks the answer. But here's the catch nobody tells you. A test only checks the cases you thought to write. It proves the situations you imagined behave the way you said they should. It is silent on every situation you didn't imagine. And the bugs that bite you in the field live almost entirely in the situations you didn't imagine. A passing test is real evidence about the path you tested, and 0 evidence about the path you forgot. Don't read it as more than it is. And the AI saying, it works, that is the softest signal in the room. The AI is telling you the code looks consistent with what you asked. It did not open the app and click through it as a skeptical human. It did not load the empty state with 0 records. It did not yank the network out mid-request to see what happens. When it says looks good, it means looks good, on paper. Treat that as a confident opinion, not a verified fact. So stack it up. Lint, type check, compiles, the AI's nod. Every one of them can be green while your software is wrong, because not one of them ever checked the only thing that actually matters. What happens to the person using it? That's the category we keep missing. We call it static success, proof about the code sitting still. And none of it is proof about the code in motion, in someone's hands, doing the real job. That's why I want you to think about verification in 3 layers, because seeing the layers is what lets you stop shipping into the gap. Layer 1 is everything we just talked about: lint, types, the tests you wrote, the AI's review. It's necessary. Skip it and you ship sloppy. But it catches the obvious, not the behavior. Layer 2 is behavioral verification, the layer most builds quietly skip. Did the form actually submit? Did the data actually save? Or did it just look like it saved? Does the empty state render? Or does the screen go blank when there's nothing there yet? Does the error message actually appear when the thing goes wrong? Or does it fail silently and leave the user staring? That is the operator's layer, running the software like a real, slightly hostile user and watching what it really does. That is what this whole module teaches you to do on purpose. And layer 3 is production reality. Real users, real messy data, real errors only visible once it's live and out of your hands. That layer needs real instruments, error monitoring that pages you when something breaks in the field, automated browser checks that drive the app like a person before anything merges, a fresh test environment spun up for every change. That's the production-grade version, and we'll point straight at it in the close. It's where premium picks up. Here's the line to hold on to. Most operators ship after layer 1, and the bugs land in layer 3. They release the moment the checks go green, and the failure surfaces weeks later in front of an actual user, where it's most expensive and most embarrassing to find. This whole module lives in layer 2, the behavioral middle that catches the bug while it's still cheap, before it ever reaches a person. And I want to be honest about exactly what we're claiming, because the brand doesn't sell magic. Static success is necessary. You still want the clean lint and the passing tests. Keep them. It is just not sufficient on its own, and pretending it is how good builds break in front of the people you built them for. There's no trick here that makes behavioral bugs disappear. There's a discipline that goes and finds them on purpose before your users do. That discipline is learnable, it's repeatable, and it's the whole point of the next 4 lessons. So we start where verification really starts, before you build anything at all. Because you can't check whether the work is done until you've decided in plain and specific terms what done even means. In Foundations, you wrote a definition of done for one build, and that was exactly right for that build. It will not carry you across a real project with many kinds of work in it. The next lesson takes that idea up to operator depth, definitions of done that travel from build to build, and the rule that has the AI reach for the right one before it writes a single line. That's where we go next. I'll see you there.